Right. Okay, so I'll continue in English if you don't mind, as French is not my native language. So I'm Nick Trogh. I'm a developer engagement lead at Microsoft. I'm based in Belgium. And so you can find me on Twitter, on other social media channels if you want to reach out to me. So when we talk about Terraform on Azure or on any other platform, basically, Terraform is actually a solution that allows you to implement in what is called infrastructure as code. And so infrastructure as code is really the concept where you kind of manage your infrastructure. And that could be all infrastructure components. So it could be networks, could be virtual machines, but just as well when we talk about cloud services, could be platform services as well. Think in the context of Azure, for example, think about an app service or an Azure function. All of those components can be managed in what is called a descriptive model. So you describe the infrastructure as if it was a piece of code. And kind of what you can see, what Sam Guggenheimer, a colleague of mine, actually mentioned is that basically the principle of infrastructure as code is that in the same way that if you take a piece of source code, let's say you take C# or Node.js, you compile or you generate an executable from it, each time you generate that from that same source code, you get the same result. In the same way, you want to have your description of your infrastructure. If you run it, it should generate the same environment each and every time, regardless of what you have already in your infrastructure. So if you modified it, you reapply your infrastructure as code, it should result in the same end result. And so looking specifically at what we kind of typically look at when we provision infrastructure, how it's been done like for many different years. We've used like scripts, shell scripts or batch files or PowerShell scripts to generate an infrastructure. And so you execute a number of steps to kind of get to the end result. And what you do in that script, well, you need to verify for each component that you install, well, do I already have a network available? Is there already a resource group? Is there already a virtual machine? If yes, I'm not going to install it. And so you need to have a lot of if, then, else cases in your script. So that makes it very, very complicated. Yeah? And so imperative is where you do you describe basically step by step what needs to happen. On the contrary, if you look at infrastructure as code, so IAC, the only thing that you're describing is the components that you need for your infrastructure environment. So you describe what is called the desired state. Where do you want to go to? So you describe the different components. You don't describe how you get there. You just describe what you need. That is called declarative. And so that's how Terraform also is working. Now, Terraform is not the only infrastructure as code technology. So there's different technologies. And so if we look specifically at Azure, there are, of course, ARM templates. And now just quite recently, we've kind of launched a preview of what is called Project Bicep, which gives you kind of a layer on top of ARM templates, which makes the description of your infrastructure easier. There's things like Puppet, Chef, Salt Stack, Eds, and so on and so on. So there's many different ones. And so today we're going to focus specifically on Terraform. And so what is Terraform? It's an open source technology that allows you to do infrastructure as code, of course. And it gives you kind of a CLI, so a command line interface to do all of these, to apply all of your infrastructure changes to a specific target environment. And so the target environment can be Azure, but could be just as well, could be AWS or GCP. It could be a local Kubernetes server, could be DigitalOcean, and so on. It does not necessarily have to be Azure. It can be different target environments. And so what Terraform uses to describe the infrastructure, and so we'll see that in the demo, is a language which is called the HashiCorp Configuration Language. So HCL, because Terraform is actually provided by a company called HashiCorp. And so they use a concept of immutable infrastructure, which is basically just another word of saying that you always describe your desired state rather than applying fixes and patches to a current environment. You always take your desired state, and you're going to apply that state to your infrastructure. And so how Terraform does it is, when you create such a configuration file, such an infrastructure script, actually it's going to parse all of the components that you need, and it's going to build what is called a resource graph. So it's going to determine all the different dependencies between the different components. So let's say you want to provision a virtual machine in Azure. That virtual machine, before you can create that virtual machine, you will need a resource group. You're probably going to need an IP address. You're going to need potentially a virtual network. So there is a dependency from that virtual machine on the resource group, on the IP address, on network security groups, all of those components. So there's a number of dependencies. And so all of those are being managed in a graph by Terraform. And so I mentioned that Terraform can not only be applied to Azure, but also to other environments. And so they enable that through a number of what they call providers, which you can actually see as plugins. So you can create your own plugins as well for or your own providers within Terraform. If you have a target environment, well, then you can actually create a specific dedicated provider for that. Now, infrastructure as code, the advantages is, well, basically that you can reproduce your environments quite easily. So you take your infrastructure script, you apply it, and it will actually reproduce that environment exactly as it is described in that infrastructure script, regardless of what is already existing in your target environment. So if, for example, taking the example again of that virtual machine that you want to apply, if, for example, the resource group already exists, or you've done already some work there, it's going to reproduce an environment, but it's not going to create that resource group anymore. So it's going to take whatever is already there and just apply whatever is needed to get to your desired state. Of course, it's part of an automation. You can track basically your infrastructure definitions easily because those configuration files are just text files. So you can put them in source control, so in GitHub or Azure DevOps, whatever you want. So you can easily track kind of the version history of those configurations. So where previously, typically an infrastructure description, if you're lucky, people are describing it either in a runbook or in a Word document or whatever. They note it down, but typically that's not being maintained or updated, and it's not easily parsable, and it's difficult to see kind of the version history. With, of course, infrastructure as code, it's just a code file. It's just a text file that you can version control. One thing to mention, with Terraform specifically, infrastructure as code is not the concept where you apply the same configuration across clouds. So because you're using specific platform-specific providers, a script for or a configuration for Azure is going to be slightly different than the script for AWS or for Google Cloud Platform. So you're using the same underlying development technology, so the tooling is very consistent across all of your clouds, and all the syntax for the configuration is the same. However, the actual script is not identical. So it's not I write it once and I apply it everywhere. It's really you apply conceptually the same things, but they're not identical. So here a quick heads up on what are the typical providers that you have within Terraform. So there's a number of clouds, infrastructure, network components. Basically, you can manage pretty much all of your infrastructure using Terraform. Now, if we zoom into Azure, because that's kind of the key topic of this session, is when we look at Azure and Terraform, we're basically using what is called the Azure provider, or the Azure Resource Manager provider, which you can see here in this code snippet, where we define basically the Azure Resource Manager provider. We give it a version number, and then we can specify some specific details there. To specify which subscription do we want to use. Also, of course, the client secrets, if we're using a service principal. If you're using the Azure Terraform in kind of an interactive way, so you're just launching it from the console, as we're going to do right now, there's no need to provide all of these client secrets and client IDs and subscription IDs. It's going to use actually the context of the Azure command line interface. So if you do an AZ, so the Azure command line interface login, Terraform is going to reuse that security context within your session. If you're using Terraform within, let's say, a GitHub Actions or an Azure DevOps context, you will need to use either a service principal, and then you'll need to provide those secrets and those IDs. Or if you're using managed service identity, again, you'll have some configuration to put in there. So Azure resources, data sources that you can use, well, you can provision as mentioned, so infrastructure services, but just as well your platform services. One question you may ask, what if Azure is evolving? It is constantly evolving, so that's obvious. But yeah, what if my provider for Terraform is not evolving at the same pace? Because typically there's a little bit of time between new features coming to Azure and new features and those features appearing in that Terraform provider. Well, you can always use, you can integrate ARM templates within your Terraform configuration. So you always have a possibility to leverage the latest features of Azure when you're using Terraform. So even if the provider is not yet up to date, you can still call into ARM templates. Okay. So with that, I'm going to switch to a quick demo. And let's first see where exactly can you find Terraform? How do you get started? And so if you go to terraform.io, which is basically the landing page for Terraform. So here you have the documentation. There's a bunch of tutorials there. And one thing that you'll need to get started on your local machine with Terraform is to download the CLI, so the command line interface. Terraform comes as a single binary. So the only thing you need, so if you're running on Windows or even Linux, you just download the Terraform executable and just put it in your path, and it will actually work. That's the only thing. It's a single executable. If, on the other hand, you're using the Azure Cloud Shell, so if we go to shell.azure.com, Terraform, the Terraform executable is already pre-installed in the Cloud Shell. And the advantage is, because the Cloud Shell is already connected to your Azure subscription, because you're logging into the shell with your subscription, it's going through a number of authentications here. So what happens is already the connection between, there's no more need to do an explicit Azure login using the Azure command line interface to start using Terraform within the Azure Cloud Shell. So this should take just a couple of seconds. And okay, let's already switch to our VS Code. While that one is logging in, it takes a bit of time to log in. So how do we get started? So I'm going to run it here locally on my laptop. So we start by creating a file to describe our infrastructure. And so we can start with, for example, main.tf. So tf is the extension for Terraform. So in here, as you can see, there's no schema there. We can do Terraform init. So how do you get started? Well, the first thing we need to specify to Terraform is to specify which providers we're going to use. So we can say required providers, and you can see that in VS Code, there's a Terraform extension, which will give you IntelliSense. And so we're going to use the Azure RM provider. There we go. And we need to specify where exactly it is. So where can it find this provider? So that one is part of what is called the HashiCorp Terraform registry. This, and we need to specify which version we want, because maybe there's multiple versions. And so we can use specify, just use version 2, and whatever detailed version there is, just use that one. Okay, so this is just specifying which version of the provider we want. And then actually what we're going to do is we're going to specify then that we are going to use a provider and configure the provider. So one thing you need to do, maybe you can want to specify some specific features. So if you're using, for example, a service principal for connecting, you will be putting here, for example, your client ID and your client secret. So this is what you'll put in here in the configuration of the provider. So for now, as we're running just interactively, There's nothing else we need to do here. So this is kind of the minimum version of a Terraform configuration file. So if I open up here our terminal, so what can we do with this now? Well, the first thing we need to do is need to initialize our Terraform project here, our Terraform environment. And so this is what we're going to do is by doing Terraform init. And so what this will do, it will actually download the providers locally on your machine. So here you can see it's installing the resource provider for Azure version 53. There we go. And now we have it. And so now we can get started. And so the first thing we need to do within a Terraform configuration, if we want to add specific infrastructure components, well, we're going to add what is called a resource. So a resource is, and here we have IntelliSense. And so we can say, typically within Azure, we're going to start with Azure RM and a resource group, typically. So let's make it RG. We're going to give it its name. So the name is actually the name that it's getting within Azure. Oh, let's call it MSDev for MSDev Roadshow. And let's give it a, of course, we need to give it a location. For example, North Europe. What else do we need to give it? I think that's pretty much it. A location, a name. Yeah, that's pretty much it. And so now we have described basically that we want a resource group to be created in Azure. And that's all we need. So within Terraform, what is kind of the workflow to get started? So we initialized the project now with the Terraform init. The next step we can do is actually do a Terraform plan. So what does Terraform plan do? It's actually going to validate what exactly are you asking me to create? So in this specific case, a resource group, and it's going to check the target environment. It's going to check Azure. What is already in place? Is there maybe already a resource group? If yes, it's going to check, maybe I need to do a patch of that resource group because maybe you're asking it to change its location, or maybe you want to add some tags to that specific resource group, whatever parameter or attribute you want to change on that item. And that's what's happening in that Terraform plan. So this takes a little bit of time, basically because it's doing all those checks and it's connecting to Azure to validate what is already existing there in the target environment. It should come up pretty quickly. Okay. So while that one is running, I can show you some more here. So you've seen me using these fixed values for name and for location. Well, as we are going to add more resources, so we're going to add an app service, they're going to have a location as well, but maybe we want to use that same location. And so what we can do is we can actually add what's called a variable. So we can add, for example, a variable called location. Its variable type is going to be of type string because it's just a string value. We can give it a description, which is, for example, the data center location. And if we want to, we can actually put a default value there as well. So we could say, for example, North Europe. Let's not do this for the time being. What we've done here, you can see that our plan has come back with a result. And so it's actually explaining you what exactly are the actions that it's going to do. In this specific case, we can see that it's going to add one resource. It's going to add this resource group at this location with this name. Okay, and so there's nothing to be changed or destroyed. Okay, so when we want to apply this this infrastructure to our environment, we will do a Terraform apply, as you may guess. As we do this, what's going to happen is it's going to, as we have already changed here, we can actually now specify North Europe as the value for our variables. You see this variable location allows us to then provide input parameters to our script. So you might wonder, well, it's asking for that variable. We have not yet used it. So we can already change our code for this. So the next time we apply it, we're going to use our variable, call called location, and that's actually going to pick up that specific location there, that variable. So that way we can actually start adding some flexibility to our scripts by using input parameters for our Terraform script by using these variables. You can store some default values as well in a separate file if you want to. So you can create a separate file with kind of all of the default values for your parameters and your input variables. Now, the next thing we're going to do while this one is applying, just to for the interest of time, what we're going to do is we're going to add a app service plan. So I'm just going to paste it here. So what you see here is actually in our script, we're adding a second resource, which is, again, using the Azure Resource Manager. It says an Azure Service Plan. We give it an identifier. So this identifier is something that you can use internally within the Terraform script. Okay, so this one, just switching back to our apply. If you apply changes to your infrastructure, you need to explicitly say yes, that you want to apply it, unless, of course, you provide a command line parameter that you explicitly confirm it. So it's going to apply, and it's going to add that resource group to our Azure environment. So what I was mentioning, so in this second resource, our service plan, what we're going to do is we're actually going to refer back to the other resource, to this resource group, because the location of our service plan is actually going to be our resource group. So .rg, which is basically the identifier for that specific resource group, and we're going to take the location parameter. The same way where we need to specify the resource group name of our service plan, we're going to use that same, we're going to refer back to this one. So implicitly, Terraform will know that there is a dependency between those two resources. So it's automatically going to create this one after that one has been created. And so one thing to mention as well, you can just as well change your script and do something like this. So you can actually put the resource group all the way at the end. So the order of resources does not really matter within your Terraform configuration. So one thing I'm noticing, it's very slow in applying the changes here. So I'll just continue here. Okay, so here you can see it's creating the resource group. It has completed for 1 second. Just pretty weird. It's taken so much time. And so now we have an Azure resource group. So if we do, let's say CLS, let's do Azure group to show the details, just to prove that it's actually there. MS-def resource group. There we go. Just calling the Azure command line interface and see if that resource group has actually been created, because maybe this was all just a trick. And there we go. So it has been created successfully. Okay. So now what happens is, and you might see this file here, this terraform.tfstate. Oops, let me use this one here. So this specific file is actually what allows Terraform to know the delta, to know what exactly needs to change when it does an apply of a resource. Because right now we have added this service plan here. So again, if we do Terraform apply directly, so if we do an apply, and now it's going to know that there is already a resource group. And it actually is using this tfstate file. And if we open this tfstate file here, oh yeah, because it's being read, and so we're going to grab. Oh yeah, sorry, something I put in here. There we go. So in this Terraform state is actually, it contains basically the current state of the environment. And so it's going to use also that to kind of determine the dependency graph and those kind of things. One thing to note, by default, you're using local state. So if somebody else is using Terraform, they don't have this state available. So if you're working in a team using Terraform, make sure you store the Terraform state in a shared location. So, for example, you can store it on Azure Storage. Okay, so let's say North Europe. Pretty much close to the end of our session here. So I'm doing North Europe to apply it, and then as we apply it, it's going to tell us that it's going to add one additional resource on top of our resource group. Okay. So there's a lot more stuff in terms of syntax. So here we're just using the basic features, but one key thing here is just for you to know, yes, you're using this Azure provider. By using these identifiers, you can actually refer back to those resources using that identifier and reuse information that you got from this specific resource, and then actually create dependencies between resources. There's a whole concept of these variables, which you can provide through the input to the console. And that's basically kind of the basic structure of Terraform. So one thing I haven't shown you just yet is, so we've used the Terraform init to initialize our project. We've done plan to kind of determine what needs to change. Yeah. So here you can actually see what's it going to add. It's going to perform an addition of this service plan, and we can say yes. So it's using the plan to determine what needs to change. Then we do apply to actually apply the changes to the target environment. We can then also destroy all of the resources with a single command by doing Terraform destroy, which is kind of obvious that we can do it that way. Okay. So in the interest of time, well, we'll let this one run for a couple of seconds. So let me switch back here to our workflow. Kind of mentioned this one. And let's switch to one thing I wanted to still mention here. So far, we've used kind of Terraform just on the command line on our local machine. Typically, you're going to integrate Terraform in your continuous integration and continuous deployment environment. So you can add it to GitHub Actions. So there's a setup Terraform action available in the marketplace. And the same thing goes for Azure DevOps. So there's also a Terraform activity that you can actually add to your pipelines, to your build or release pipelines. And so, as mentioned, make sure that you use shared state for your either Azure Storage, or Terraform also comes with what is called Terraform Cloud, which is a cloud-hosted environment for Terraform, especially when we're working in teams, where you can actually share your state as well. Okay, so here, this is pretty much how you would set it up in GitHub Action. One thing to mention there is, as you are not running interactively, as mentioned, you need to provide kind of the client secret to be able to connect Terraform to your Azure environment. So those you will be setting to a number of environment variables in your GitHub Actions script. And so the same thing goes for the Terraform activity for Azure DevOps, where again you will be providing the specific key to be able to connect to your Azure environment. Yeah, so this is how you would do this. A number of resources, Terraform on Azure. So we have some documentation available for you that kind of goes through the different steps and different how-tos. How do you set up an Azure App Service? How can you set up, for example, a Cosmos DB? How do you connect to Azure Storage for sharing your state amongst a team? And again, also the links to the kind of GitHub and Azure DevOps plugins for you to integrate Terraform in your CI/CD process. So I'm going to, for the last time, switch back to this one here. And we can actually see that our Azure service plan has been created. And you can see that one was added. So whatever modification that you then make afterwards to these resources. So let's say, for example, instead of using an S1, you want to use an S2. Basically, Terraform will detect all of the changes that need to happen And so that is happening automatically. And again, we can say North Europe. Oh, one thing to mention as well, if you make modifications in the Azure portal to those resources, Terraform is going to detect as well, and it's going to switch back whatever is provided in your Terraform script. So this is kind of cool as well. If you have somebody that makes modifications in kind of the production or in the Azure environment directly without going through Terraform, as you do in Terraform apply, it's going to actually override again those changes that were made manually with whatever you have defined in your basically your configuration in Terraform. So really to give you that consistency that whatever you describe in your configuration is what you will end up with in your Azure environment. So the concept of a desired state, you describe what you want to have in your configuration, and that's exactly what's going to be available in your target environment. Okay. I think with that, I've gone probably slightly over time. If there's any questions, let me switch back now here to the